Hello friends, welcome to my channel, myself Parag Jambulkar. In this video, we will discuss about VLIW architecture. Before that, in last video, we have seen scalar architecture, superscalar architecture. The processor which follows scalar architecture will be called as scalar processor. In the same way, the processor which follows superscalar architecture will be called as superscalar processor, and the processor which follows VLIW architecture will be called as VLIW processor. Now, just as a revision, scalar architecture means the architecture or processor which works on scalar quantity. So, for example, ax plus bx or addition of 2 plus 3. So, processor which performs operations on scalar quantities is called as a scalar processor. Now see, here only one pipeline is used to perform this operation. Instead of that, if you have multiple pipelines, so you can perform multiple operations together, and that architecture or that processor is called as superscalar processor. That's why it is an advanced version of superscalar processor. So here there are multiple pipelines. So one pipeline will do one operation, at the same time another pipeline can do multiple operations. Suppose it is an n-way, or if it is a 4-way superscalar architecture, so it can perform 4 operations together. So there will be 4 pipelines. So these 4 pipelines will perform 4 operations together. But problem with the superscalar architecture is, if these instructions are linked together for some data or resources, they have some dependency for data or resources, then we cannot perform these 4 operations together. So how many operations we can perform together is limited in superscalar architecture, as there can be dependency among these different operations. So solution to that is VLIW architecture. VLIW stands for very long instruction word processor architecture. Very long instruction word. Now see, in superscalar architecture, as you have said, if it is a 4-way superscalar architecture, so 4-way superscalar processor, so it will perform 4 operations together. But if there is a dependency, so it cannot perform 4 operations together. So what we are doing here, this is the processor which will perform these operations. So before giving this instruction to the processor, we have a compiler, and what this compiler will do, it will choose the operations which can be performed together. So there will be no dependency in between. So these 4 operations will be combined together, and these 4 operations will be given to the processor for execution. In the same way, this compiler will form another 4 operations. It will group another 4 operations, and those 4 operations will be given to the processor. In the same way, it can group some operations and it will be given to the processor. These 4 operations or multiple operations are passed as a word. Word means collection of bytes. But as there are the multiple instructions, it is called as very long instruction word. So that's why we got the name very long instruction word processor, VLIW processor. How compiler choosing this operation? So definitely one thing is there, they should not be dependent on each other, and one more thing is dependent on how many functional units are provided by processor. For example, suppose our processor has provided 2 functional units for load and store operations, one for addition and one for multiplication. So compiler has to group operations, so it cannot take 2 addition operations or 2 multiplication operations, as processor is providing only one function unit for one addition and one function unit for multiplication. So how compiler are grouping them? Based on there should not be dependency, one thing, and how many functional units are provided by a processor. It will discuss advantages and limitations of VLIW processor. So first thing is it simplifies the dependency. As we have seen, that was the disadvantage of superscalar architecture or superscalar processor. So it simplifies the dependency at compiler level only. Then it reduces the hardware complexity, as most of the work, for example fetching, decoding, these works are done at compiler level, so there is no hardware support is required for these operations. So these are the advantages of VLIW processor. While if we talk about the limitation, it increases the software complexity. Software in the sense it increases the compiler complexity. So more optimizations are required or for grouping that work is done by the compiler. So that it has increased the workload of compiler. First thing. Then it cannot work in dynamic environment. Why it cannot work in dynamic environment? Because all the instructions we should know before only. Dynamically if you get another instructions or another operation, so we cannot schedule it. So in advance we should know what operations or what instructions we have to perform, so that compiler it can group properly. And it is also dependent on the functional units provided by the processor. So already we have seen it. How many functional units are provided by the processor, based on that compiler has to group those operations. So these are the limitations of VLIW processor. These are the examples of processors which uses VLIW architecture. So multi-float trace, Intel i64. These are the early processors which uses VLIW architecture. Now let's take an example of this. D is equal to ax plus by plus cz. So I have to calculate this value. Now what operations are here? We have to load a, we have to load x, we have to multiply. We have to load b, we have to load value of y, and we have to multiply. In the same way, we have to load c, we have to load z, multiply. Once multiplication is done, we have to add them. After that, once multiplication is done, we will add this value to this. So around there are 11 operations. So if you use scalar processor, so around we require 11 cycles. So for each operation there will be one cycle. Now see, same thing if we do by using VLIW processor, so we can group these two operations together. So we will load a, we will load x. So these two operations can be performed together. So these two operations will be done in one cycle. Now we can load b, we can load y. Already these two things are loaded, so we can multiply. So we will multiply a and x. So these three operations can be grouped together. Loading of b, loading of y, and multiplication of a and x. So these three operations can be grouped together and can be done in one cycle. Next time we will load c, will load z, and we can multiply b and y. So these three operations can be done, and that will be done in one cycle. After that, we can multiply c and z, and already we have value of this, we have value of this, we can add together. So we can add, suppose this multiplication is saved in ax, this multiplication saved in register bx. So we will add this, and suppose we got value in x. Now in next, so that will be a fourth cycle. And next, so we have addition in ax and this multiplication in cx register. So we can add together, so we'll get result in x. So that will be a fifth cycle. So if we use VLIW processor, so all these operations will be grouped together. So these operations are independent. These are not operations are dependent on each other. So we will require 5 cycles. But if independently if we do these operations, so around if you use scalar processor, so around we require 11 cycles, and if you use VLIW processor, we require only 5 cycles. So friends, I hope you like this video. If yes, then click on like, subscribe to this channel, and don't forget to press bell icon so that you will get notifications of my next video. So stay connected. Thank you.